The temperature of a body is directly proportional to the mean kinetic energy of its particles. Heating increases the speed of the particles. Cooling decreases the speed of the particles. In the next simulation, particles get energy from the walls of the container, while the system of 25 particles heats up. Particles lose energy when colliding with the walls of the container, while cooling. Collisions between particles, with the same or different masses, are elastic. If temperature remains constant, collisions with the walls are made elastic. If the system cools down, collisions with the walls are made inelastic. If the system heats up, collisions with the walls have coefficient of restitution higher than 1. These simulations compute collisions according to real physics, allowing credible transfer of energy between particles and, so, to obtain results in accordance with the kinetic theory. Temperature is a property of a system of particles. It measures the energy of the system. Temperature is proportional to the mean kinetic energy of the particles. If the temperature of the system has a 4-fold increase, the mean speed of its particles have a 2-fold increase. If two systems, at the same temperature, are made of particles with different masses, the mean velocity of each kind of particle will be different. Mass and the square of the magnitude of the mean velocity are inversely proportional. Particles in system A have higher mass. So, they are slower. If the system has two kinds of particles, with different masses, the mean velocity of each kind of particle will be different. The temperature is the same for each set of particles. So, if, in one of the sets, the mass of each particle is 9 times higher than the mass in the other set of particles, their speed will be 3 times less. Fast particles will escape from a given volume at a higher rate. They will diffuse more quickly. In the next simulation, collision with walls will be counted as escaping. The rate of escape equals the rate of the mean speeds. The magnitude of the velocities of the different particles in a system is not the same for all. That is why we refer to the mean speed. When temperature rises, the mean speed and the most probable speed increase. But, it also increases the spread of the velocities, with entropy. The magnitude of velocities of molecules in a gas are of the order of magnitude of the speed of sound in that medium. As very few molecules have velocity magnitude high enough to move a body with much higher mass, as a pollen particle, this body experiences an erratic movement inside the system, impacted, now and then, by one of these high-speed molecules.